In this video, we are discussing how to graph when we have slope-intercept form equations. So first of all, just a reminder, slope-intercept form is y equals mx plus b, where y and x are our variables. M is our slope and how the line moves. And b is our y-intercept, which is where the line begins. Keep in mind the y-intercept part means that this is on the y-axis. So we're using that vertical axis to start our equation. Our first example, we have y equals 7/2 x minus 2. So what I recommend is first identifying the slope and the intercept. Remember the intercept, the sign matters, so please remember to catch that negative when it appears there. And then the slope is whatever is being multiplied by x, not including x, not x itself, but whatever's being multiplied by x. So 7/2. This is rise, 7 rise, 7 up, and 2 is our run, so 2 is our sideways movement. So to start this off, I'm going to begin with -2. Starting at the origin at all times, I'm going to move down to -2, and that is my starting location or my beginning for this line. From here, I'm going to use this slope, which is 7/2, to rise up 7, which gets me to 5, and run over 2 to get my line matched up. Okay? I'm going to connect those dots and extend them a little more. Make sure to use arrows in both directions so that way I can clearly see that this line is never ending. This next example, we have -6x plus 3. So y equals -6x plus 3. Again, I'm going to find my slope and my y-intercept. My intercept is +3, so I'm going to plot a point at +3 on the y-axis. My slope is going to be -6. Now, since that's an integer, I'm going to put a denominator because that's going to help me with my rise over my run component. And that run part is really important. So I'm going to move in a downward direction because it's negative. I go down 1, 2, 3, 4, 5, 6, and then over 1 to the right. Now I'm just going to simply draw my line through, and I have my equation drawn. For this example, we have a slightly special circumstance because you might notice there is no slope. There's no x value for us to have a slope. B is at -5, so I can see on the graph where -5 is. Right? But I got nothing in there. That's because where y is equal to -5, that's my answer every time. That actually has no specific slope because it is the slope of 0. This is a unique situation as well. And this time, instead of having a y, we have an x. So there is no b value, all right? There is not a b value. X is equal to 5. X is equal to 5 here. X is equal to 5 there. X is equal to 5 here. So when you have an x equal to something, not a y, you're looking at the axis, the x-axis, of course, and we call this an undefined slope. We will talk more about undefined slopes as we approach relations and functions, but it is important to notice that x being equal to 5 results in an undefined slope and is a vertical line. Give this example a try on your paper and be sure to check in with Mrs. Jackson or another peer to see if you got your answer right. Give this one a shot on your paper and make sure to check it with a peer and with Mrs. Jackson. Last example, I do want to talk briefly about a situation like this where we have our m and our b. Now our b value, our y-intercept, is +4, shouldn't be too tough. But what is with x? Well, it is a -1, which is pretty common to drop that 1 there because the negative tells us all we need to know. But it is not a fraction yet either. Anytime I have a negative in front of an x or with an x being multiplied, that tells us that we have a negative slope, but also that we need to be mindful of moving in a downward direction and not an upward direction. Make sure to get your work checked when you need it, and if you do have any questions, go ahead and pause your video now and go ask them and get to work.